So uh, so now let's take a look at the code. Here I have this a sketch open in this Arduino IDE, and I have written this whole code. This will allow us to execute our logic, our line following logic. Yes, the same awesome logic. So basically here you can see that we have three pins. We would be using three pins in digital mode. This one is the sensor pin. The input we are taking from the sensor, and these two are the output pins, the motor pins. This is the motor pin for left motor, and this is the motor pin for the right motor. So here now I am assuming that you have some basic understanding of Arduino as well. So here is the infamous setup function of the Arduino, and here we are telling it to set the sensor pin to the input, and we are telling it also that these two pins we are going to be providing some output there. So this here comes then the loop. The program enters the loop. This loop keeps on repeating itself. It goes to the end of the code, and then it comes back here. So now in this loop we have this integer sensor value. What it does is it basically goes and reads the sensor value. So to take an example, let's assume that this is our robot again in top view. This is the left motor. Here we have this is the right motor, yes, along with the tire. This is the front sport wheel, and here let's say we have a sensor. Now let's say that this is the line. This is the line we are trying to follow. I'm just coloring it black here, just these in these diagonal lines. Actually it's all black. So this is the line we are trying to follow. So here in this we're assuming that this is our sensor value, which is attached to the pin 1 of the Arduino, which is the input pin again. And here it digitally reads the value of the sensor into this integer. Now remember that this digital read gives us a 0/1, and again, like I have said many times, in case of sensor, a value of 1 implies that it's black, and a value of 0 implies it's white, right? So here then we comes the if condition. Here we check if the sensor value is high. No, this one actually also means high in Arduino language. It's actually C. It's just a defined parameter, and this is, you can say, low. This is just to take an understanding of high and low. Plus 5 volts, you can call it 1, you can call it high, and here it's 0 volt, you can call it ground, and low, all that stuff. So this no in this case, in this particular scenario, in this picture we are currently talking about, this is 1, this is high, right? Because the color is black, which implies there is a line and we should now turn left. Now these are the lines of code which needs to be executed to turn this motor, to turn this robot to its right. So this would stop this motor if it's already running, or if it's already stopped, it would stop and it would start this motor. This motor would stop. This would allow this tire to move forward, and this would result in, currently it's like standing here, so it would turn here and ultimately it would stay here. So let's say this is the new uh, output new state of our robot. It's bit out of shape now, but let's just assume that's the case. And here is the this is again our IR sensor. This is again our IR sensor, this one, and this is the motor, left motor and the right motor, right? You get the point. So now it would then it would turn the motors. It would cause the robot to get into this state. It would then go for for about 50 millisecond. Now 50 millisecond is a very small amount of time, very tiny small tiny amount of time. You probably won't even note it, but this sometimes it's necessary. It's necessary for the microcontroller, so it's just a good practice to add this delay here. So it would then again come here. It would then since it's in a loop function, it would again read this value. Now in this case, now right now the value would be low, that is 0 volt, which implies that the color, this condition is no not true. This implies the color is white and that there is no line, that now we are here out of the line space and we should not turn right. Now to turn right again, we have to execute these two lines of code, and it would then stop this motor, the right motor, and it would start steering this motor, right? And it would then turn this motor here, sorry, the robot here, and ultimately the robot would go in that direction, and it can probably end up in this direction, right? This is our left motor, this is sport wheel, this is right motor and right wheel, and here is the sensor again, right? You get the whole point. And this thing, this zigzag 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 continues, right? So that's the point. Now since it's in a loop, it's an infinite loop, so it would just keep on going if this in this way. So this is the Arduino code I have written in Arduino. Now you can also go ahead, I have also uploaded this file in resources. You can find it in resources. You can go ahead and write this code yourself, or you can copy from this. You can create a project and add here, and you can now you have all the code, all the schematics necessary for getting this stuff done, and you know all have all the logic, right? So you can now get this project done by yourself. One more thing, in next video, and I am going for simulation. I am going to simulate this code I have just written to verify. Simulations are a great way to verify your code before actually getting it to the hardware. Sometimes it's necessary, sometimes it's just a requirement. It basically prevents hardware design failures, and for many other stuff you have to actually buy a lot of hardware to know that you have it can actually get the stuff done or not, so you can just simulate it. There are many other advantages of the simulation. That's it for this video. Next video is going to be on simulation to verify this code.